All right, we're back for video number 3. We've got example 3. This time we are being given the graph. We're not given the properties, we're not given the equations. We're just simply being given a graph. And on top of that, they're asking us to write 2 equations for each example. They want a sine and a cosine function, which isn't that difficult. But let's get started. So the way I approach these, the way I recommend you approach these, kind of a surefire way, it works every time. But it's as simple as you start with identifying your properties. So amplitude, period, phase shift, and vertical shift. Because what we can do is we can identify from the graph those 4 properties, and then from those 4 properties, like example 2, we can write those properties as our coefficients a, b, c, and d, finally getting then to the equation itself. So amplitude. So the first thing, actually, what I would recommend we do is let's identify our midline. And I said this in class, but identifying the midline helps us in a couple of different ways. So there's that midline right there. And I knew that was a midline because to get from -3, so there's 3 units below the x-axis and 5 above. So to find that midline, however you want to do it, it's 1. What that tells us, right away we can start filling some stuff in. Just by finding the midline, we see that that's at 1. We know our vertical shift is 1. Our amplitude also, we can look at that midline and say that from there to our peak, that's our amplitude, and that is 4. Our amplitude is just 4. Now, looking at this for period, this graph, I'm going to see now my x-axis coordinate of this peak is -1/2. If I come over here to the next peak, I'm going to drop that, I'm going to follow that line straight down, that's 1.5. So if I'm 1.5 to the right of the y-axis and I'm half to the left, that just tells me my period is just 2 units. Because there's no pi involved in that, they're just numbers. So period's 2, our phase shift, well, this is where we have to be careful because it depends on what we're talking about. So I'm going to write this as a sine function first. And our sine function should, like for example, I'm going to say this line, this dot right here, that intersection of the midline with the graph, that's where sine should have started. But it didn't. So that should be over here on the y-axis. That's where it should be starting. So I would say that that is a phase shift to the right of 1 unit. So phase shift is 1. Again, that is for the sine curve. So let's keep going here. I'm going to draw kind of a separator here. Let's go with green. A equals B equals C and D. So a lot of these is transfer over. Our amplitude is absolute value of A. Our phase shift is directly C, a vertical shift directly 1. Our period in this case, though, PD, we know it's 2. We know that the equation for the period is 2 pi over B. So if we set those equal to each other, B is 2 pi over 2, or B is equal to just pi. So we found that. Let's see, I got some room down here. So I will write our answer in a different color green. All right, so our f of x is a times sine of b. Oh, b was pi. Sorry, I didn't put that in there. Pi times the quantity x minus c plus d. So there you go. That's our sine function. Now, I'm going to continue by writing our cosine. And if you look at what happens, the difference between a sine and cosine, the amplitude did not change. The period does not change. In fact, the vertical shift also doesn't change. So I'm going to be able to put in the same amplitude, period, and vertical shift. So I can fill all that out without having done a single piece of extra work. What I do need to do, though, is look at that phase shift. So this one here, it's really up to you. There's two obvious choices, I would say. Choice one is, first of all, cosine starts at a peak. Cosine of 0 is 1. So the xy coordinate would be 0, 1. So you can look at this either as a phase shift to the left of 1/2, or you could say that this has been phase shifted right by 1.5. Either way works. Because we haven't done a shift to the left yet, I'll just demonstrate that one. So if instead our PS, our phase shift, was -1/2, C is -1/2, x minus C becomes x minus -1/2, which really just becomes x plus 1/2. So if you want to check this, go ahead, put both of these functions into Desmos. 4 sine of pi of x minus 1, all plus 1. Then in the next line, do the same thing, but with cosine. 4 cosine pi of x plus 1/2, all plus 1. And theoretically, that should give you the exact same curve, one on top of the other. All right, so let's look at the next one. Next one should be a lot faster, though, right? So let's go back. We're going to hit some identifiers. So amplitude, period, phase shift, vertical shift. Right? All right, so our amplitude, well, again, make sure that first thing we do is find our midline. So the peak of this curve is -1 and the valley is -5. So I'm at -1, -2, here's -3. So, I am a little off on my lines. Sorry, my pen was not showing me correctly. So here, that's our midline. And so from there, we can find our amplitude and our vertical shift. So amplitude is 2. Our vertical shift is down 3. In this case, our sine, see, we should be, this pi over 6 mark, that should be as the midline, should be on the y-axis. It's not. So our phase shift for sine is pi over 6. And our period ends up being, well, there's a valley here, there's a valley here. That distance, so there's 5 pi over 6 here, 5 pi over 6, and there are 19 pi's over 6 on this side of the y-axis. So that's a grand total of 24 pi over 6, which reduces to a period of 4 pi. So that's our A, that's our C, and that's our D. B, so let's see, 2 pi over B equals 4 pi. Switch them around. B, 2 pi over 4 pi. B is just 1/2. So we have f of x is equal to amplitude 2 times sine of b 1/2 x minus c, pi over 6, minus 3. We also have f of x amplitude 2. This is our cosine function. Period did not change. vertical shift did not change. Again, it does not matter. This one here, we only really see one peak. So that's what I'm going to do, is use that peak and say that we've been shifted to the right. So x minus 7 pi over 6. So again, the standard form of our equation is b times the quantity x minus c. So because the form is x minus c, our positive shift to the right, 7 pi over 6, looks negative because it looks like x minus 7 pi over 6. But the minus is simply because our standard form started with a minus. So there you go. Those would be our answers for example 3, part 1 and 2. I don't even think they're labeled. Nope, they're just 2 examples. So there you go. Sorry it took so long, but that is example 3. And that is it for this video. We're on to word problems next.